do, we can make, for example, like I said, you can make alpha the subject and substitute it in here, okay? And see what happens. And then substitute in here, and then you're gonna have, and then you're gonna be able to find the answer for gamma. All right, I'm gonna simplify this equation. I'm going to simplify this equation, and I'm going to call that equation 1, all right? Okay, so this is equal to 2 alpha plus gamma equal 5. Okay. So we're going to say from 1, we can say that 2 alpha plus gamma is equal to 5. And then we're going to substitute. Okay, so we're going to, first of all, we're going to make delta. So we can make gamma. You see, gamma the subject. And so we're going to say, so gamma is going to be equal to 5 minus 2 alpha. And then we're going to substitute that in the second one. Can you see that if you substitute gamma in here, then you're going to have an equation of one variable only? Okay, let's do that. So, and then we're going to say sub into the second one. And that will give you, you tell me. So you're going to be alpha square plus what? Alpha multiplied by 5. That's going to be
5 alpha.
Yeah, so it's going to be alpha multiplied by 5 minus 2 alpha, and then plus alpha multiplied by gamma. So it's going to be alpha multiplied by, yeah, can you see that in here we got two of them? Yeah, so we can say this. So we can put the 2 at the front, and then we can make that equal to 7. And then I want you to solve this equation for alpha. Can you see that this is going to be a quadratic equation? All right? Okay, so let's continue. So we're going to have alpha squared plus 10 alpha, and then minus 4 alpha squared equal 7, right? Now, can you see that if we find the answer for alpha and gamma, then we can find the answer for k, all right? So that is our goal. Okay, can you please find from here, this is a very, very simple quadratic equation that you can solve. Okay, so this is the same as if you do, okay, so you're going to put this as negative 3 alpha squared plus 10 alpha minus 7 equal 0. Okay, and then you're going to solve that equation using any method you want. Okay, so you can use the quadratic formula, you can factorize if you can. Yeah, so can you please find the answer for that? Okay, so I'm going to write that equation in this form. So I'm going to put 3 alpha squared minus 10 alpha plus 7 equal 0. Okay, can you please solve that quadratic equation and tell me what the answer is? And then we're going to come back here just to make sure that you understood, you know, each one of these steps. Okay, but let's solve that.
Shouldn't that be minus 7?
Yeah, I changed the sign. Right, have a go and tell me what the answer for alpha is. And you can see that we're going to have 2 value of alpha, so we expect to have 2 because it's quadratic.
So we just find the roots.
Yeah. So we're going to find the solution for that equation because that will give you the alpha.
I got 1 and 7 over 3.
Okay. So after a little bit of manipulation, you say that you have alpha is equal to, what was it?
I had 1 and 7 over 3.
7 over 3. Okay. Has anyone got the same? Yeah? All right. Okay, so that means that we're going to have then two solutions for gamma. Okay, so we're going to come back to that one. So I'm going to call that asterisk, so then we can refer this. Okay, so we have that. And we're going to say for alpha equal to 1. Okay, now we're going to say for alpha equal to 1, we can find the answer for gamma, all right? Okay, so I'm going to say for alpha equal to 1, we have gamma is equal to 5 minus 2 times 1. So that will give you 3. Okay, so we have, and then for alpha equal to 7 over 3, gamma is going to be equal to 5 minus 2 times 7 over 3. Can you please tell me what the answer for that is? 5 minus 2 times 7 over 3.
1/3.
1/3. All right, that's it. And then we are sort of ready.
Does that mean that it has 2 double roots?
No. This equation got nothing to do with the original one.
Oh.
Okay, so this is the one that have 2 equal root. Okay, so but when we did this, happened to have another equation to find alpha and gamma. Okay, but let's check this. Okay, so I don't want to just continue. So we're gonna make sure that we understand everything. Okay, do you understand the question? Okay, do you understand that when we say that we have 2 root or double root, then 2 of them will be the same?
Yeah.
Do you understand that? Are you okay when I did this? Can you see that normally we say alpha, beta, gamma? Okay, but because 2 of them are the same, then I say alpha, alpha, and gamma. Is that okay? Yeah.
If you said beta and beta, will that still be the same?
Still the same. Still the same. It doesn't matter. You can have alpha and then gamma and gamma. Doesn't matter. Okay, now, do you understand where this is coming from? Okay, do you understand where this is coming from? And that one? Okay, so that means that up to here, we are all okay, right? Okay, so when I say that up to here, we are all okay. Do you understand this line now? Okay, this line is coming from here, right? So I just make it simpler. And then, do you understand why I made gamma the subject? Okay, because I really want to substitute that into, this equation, so then we can have an equation involving only one variable, right? Are you okay with that? Mm-hmm. Okay, so do you understand how we went from here to here and to here? All right, so we're going to take that one. All right. Okay, so then we have this quadratic equation, okay, and then when you solve this, that will give you 2 answers. So one of the answers is going to be alpha equal 1, and the other one is going to be 7 over 3, right? Okay, so that is telling you that we're going to have 2 answers for alpha and 2 answers for gamma, all right? Okay, so therefore we're going to have also 2 answers for k, all right? Because that's what we need to find. We need to find k. Poor k, we have, k waiting there, yeah.
How can there be 2 answers for K?
Because
Like,
Okay, let's check. Let's check.
I don't know.
Because there's two answers for the other two, so you can substitute different ones in.
All right, so from here,
Will I be equal?
but let's see. Okay, I'm saying that we expect to have two answers for K because we have two pairs of solution.
Yeah.
Okay, so that we have 1 and 3, and the other one is these two. Okay. So we're gonna call this. Okay, we're gonna call this triangle.
Oh,
Yeah.
delta.
Or delta. All right, let's
Yeah.
call that delta.
Is delta?
So from delta, that is the capital delta if you want. Okay, so from delta we have that alpha square multiplied by gamma is equal to minus k. Or is that okay if I do k is equal to minus alpha square gamma? Yeah?
Let me check. Yes,
Yeah?
that's all good in my books.
Okay. And then we're going to substitute. So therefore we have k equal. Now we're going to substitute what we know about alpha and gamma, right? Okay, so we're going to substitute the first pair. So it's going to be minus 1 square multiplied by 3. So that will give you the first value for k, which is negative 3. Finally, we have an answer for k. Okay, and then in case that if we use the other values, okay, also, or we're going to say, or k is equal to minus 7 on 3 square multiplied by 1/3. So that will give you the next answer for k, which is
It better not be negative.
1 square multiplied by 3.
I got like negative 49 over 27.
Wait, why is it negative? Oh, because the minus are different.
what is it? So this is going to be 49 over 9. I mean, yeah, 49 over 9. And then we simplify with 1/3, so it's going to be what you say. So it's
49 over 27.
negative 49 over 27?
Wow.
Yeah. Meaning this. Okay, so now we're going to try to find a meaning for this. If I want to have in your test an equation with a double root, I do it like this. I can do it in many different ways. But if this is one of the way. So all I have to do is do all this, and then I can use k equal 3. So if I put negative 3, so if I put negative 3 here and solve the equation, I know for sure that I'm going to have two equal solutions. Right? That's it. Okay? So for a mathematician, finding that sort of thing is good because, you can create your own equation, you can create your own function, you can set up some conditions for your function, so you can do a lot of stuff. And remember that at this level is just mathematics, is basically algebra. But in real life, you can apply this in many situations. Okay, so you can apply all these to model real life situation. Yes, sir.
So the reason why we've had to do all this alpha and gamma is because it's a double root.
In this case, yes.
But because when we had to find k before, we didn't have to use alpha and gamma and all that stuff.
That's
Because
correct.
But they told us other stuff.
Yes.
Like we don't know what any of the remainders are or,
Yeah.
or factors.
Yeah.
So that's the only information we have.
Yeah.
Okay.
And it's all depending on the question. Okay, so in here we have all that information, and this is one of the ways that we can find, that number there. So then when we solve that equation, we know for sure that we're going to have two solutions. Yes.
If it's got a double root, it's got two the same roots, but how come when we found alpha and gamma, there's none of the same?
No. In here, what was the answer for alpha?
1 and
One.
Okay, and then gamma was.
3 and 1.
Okay, so I mean that the other one have to be one or the other. So if you substitute, if you find the other solution, then yeah, you're gonna have that the other one is gonna be the same. Yeah.
So with each one, they'll satisfy the equation that they're like the same
Yeah,
for each different.
that's correct. Yeah.
Can we use K and then work backwards to find alpha and gamma, and will we get?
No.
No, but look, in here, can you see that we have three solutions, right? Okay, so we have alpha, which is equal to what?
1.
Yeah, but we have alpha twice, all right? So we have alpha and alpha, so we have the same thing. Can you see that? So we got alpha equal to 1, and alpha equal to 1, and gamma equal to whatever the other answer was, 3? Okay, that is one solution. Or we can have 7 over 3, and whatever the answer for gamma was. Yeah, we have two equal solutions and gamma.
And they will, as a parabola,
When you sketch it,
they'll look exactly the same.
yeah.
Could you sketch it for us?
How?
Just so
'Cause
we
they-
understand. Well, for me.
Yeah.
No. What? I don't know what you're saying.
Like,
Can you
This-
sketch them?
yeah. Can we sketch them both
Yes.
and show us how? Like, when we solve it with one of the K values, we're gonna get 3 answers,
Yes.
and then when we solve
Two of them will be the same. So I mean that we're going to have a situation. Remember that if you have two solutions, and this is a cubic, so probably we're going to have something that looks like this.
Yeah.
So in here we're going to have alpha, and in here we're going to have, the gamma.
But then you solve it with the other K value, and you get another one.
The same picture?
Yeah.
No, it's going to be a different function, but it will behave the same. So also we're going to have double root. So it's probably, can you say that for k, okay, let's say that for k equal -3, we sketch, and let's say that we have that picture, right? Okay, and then for k equal, what was the other one? K equal -49.27. So if you sketch that one, obviously we're not going to have exactly the same picture, but we know for sure that it's going to touch the x-axis at one particular
So
point.
we have two.
Possible graph that will behave in a similar way or identical in that particular point.
And so they're both the equation, or is one addition of the equation?
So we got two possible equations.
Okay.
Okay, one when k is equal to -3, and the other one when k is equal to -49 on 20.
Definite equation?
Hmm?
Is there a definite equation? Because you said possible equation. Is there a definite equation?
We have to. Definitely we have to. Yeah.
What if instead of doing 1 squared times 3, it was 1 squared times 1/3? Because that would change the answers for it.
But
How do we
why-
know which ones to do? So if we
Because
did,
the one you sub in has to be the same one.
So for the first part, we have to use that number and that number. Okay, it's no way that you're going to use one from here and the other one from the other side. Okay,
Oh,
yeah, we have to use it in pairs.
okay.
Okay, let's do another question.
Well, wait.
Yeah.
How did we find K? Can you please explain that little section?
In here,
You've got the last
Yeah.
thing, and you know it alpha.
so we know already what alpha and gamma are. Okay, okay, and we know that
I mean,
k is equal to that, and k is that k is given in terms of alpha and gamma.
yeah.
So if you know what alpha and gamma are, then you can find k.
Well, like,
That's what we did.
you didn't do negative K, you did K. You put negative in front of the alpha, but not the gamma.
Because they
They're
multiply.
multiplied by each other.
Yeah. All what I did is just to Sean.
Yeah.
All what I did is just to make K the subject from here. So if you make K the subject, then yeah, obviously
I
you're
was
going to
just
have.
confused about that
Yeah.
negative because it don't register that L multiply.
All right. Are you okay now?
Yep.
All right, let's do another
we have
question.
2 answers for each, right?
Yeah.
2 for alpha, 2 for gamma. So wouldn't we have 4 different things, or would 2 be the
Yeah,
same?
that's what Archie just.
That's what I was just saying, because when you do it, but what Nim said was, see how you've got for the first one, for if alpha equals 1, you've got gamma is equal to 5 minus 2 times by 1, so you've got to use the 3 because you used the 1 from alpha. And for the second one, because you used the 7 over 3 from alpha, you've got to use the 1/3 from gamma.
That's it. Okay, so we have two. We have 2 pairs of solution. Okay, this is one pair and another pair, and then that will give you